Isaac Newton was an English mathematician, physicist, and natural philosopher whose work shaped the foundations of modern science. He lived during the scientific revolution and is widely regarded as one of the most influential figures in the history of science. His ideas on motion, gravity, light, and mathematics became central to scientific thought for centuries. Newton was born in Woolsthorpe, Lincolnshire in late 1642, according to the calendar used in England at the time. He was born prematurely, and his father, also named Isaac Newton, had died several months before his birth. His mother later remarried and left Newton in the care of his grandmother. This early separation influenced his solitary nature, which continued throughout his life. As a child, Newton attended local schools where he showed limited interest at first. Over time, his abilities became more apparent, especially in mechanical skills and careful observation. He built small machines, such as windmills and water clocks, which demonstrated an early talent for practical problem solving. In 1661, Newton entered Trinity College at the University of Cambridge. His studies were based on classical texts, but he also read modern works in mathematics and natural philosophy. During this period, he encountered the ideas of thinkers such as René Descartes and Galileo Galilei. These readings influenced his developing approach to science, which emphasized mathematical description and experimentation. Newton received his bachelor's degree in 1665. Soon after, the university closed temporarily due to an outbreak of plague. He returned to Woolsthorpe, where he spent an extended period working independently. During this time, he made several major advances that later became central to his reputation. During this period, Newton developed early ideas about calculus, which he referred to as the method of fluxions. This mathematical approach allowed him to analyze change and motion in precise terms. At the same time, he began to explore the nature of light, experimenting with prisms and observing how white light separates into different colors. Newton also started to consider the motion of objects and the forces acting upon them. He examined how bodies move both on Earth and in the heavens. These reflections laid the groundwork for his later formulation of universal gravitation, which proposed that the same force governs both falling objects and the motion of planets. In 1687, Newton published his most famous work, a book commonly known as the Principia. In this work, he presented 3 laws of motion and the law of universal gravitation. He used mathematical reasoning to explain the movement of planets, moons, and objects on Earth within a single framework. The Principia became one of the most important scientific works ever written. During this period, Newton's reputation grew widely across Europe. His methods showed how careful observation, experimentation, and mathematics could be combined to explain natural phenomena. These principles became central to what is now known as classical physics. In addition to his scientific work, Newton devoted considerable time to other studies. He wrote extensively on theology and biblical interpretation. He also carried out research in alchemy, which at the time was closely linked to experimental chemistry. Much of this work remained unpublished during his lifetime. In the late 1900s, Newton moved to London and accepted a position at the Royal Mint. He later became Master of the Mint, where he was responsible for overseeing England's coinage. He approached this role with the same precision he applied to science, supervising reforms to combat counterfeiting. Newton was elected President of the Royal Society in 1903, a position he held for many years. In 1705, he was knighted by Queen Anne, becoming Sir Isaac Newton. This honor reflected his standing within English society and the scientific community. Despite his achievements, Newton's later years were marked by conflicts. One notable dispute involved the development of calculus, which was independently developed by Gottfried Leibniz. Arguments over priority led to lasting divisions among scholars and affected Newton's reputation during his lifetime. Newton continued to revise his scientific works and remained influential well into old age. He lived much of his later life in London and maintained a strong presence in scientific and public affairs. Over time, his health declined, though he remained mentally active. Newton died in London in March 1927. He was buried in Westminster Abbey, an honor reserved for figures of national importance. His burial reflected the high regard in which he was held at the time of his death. The long-term impact of Newton's work has been profound. His laws of motion and gravitation dominated scientific understanding for more than 2 centuries. They provided the framework for engineering, astronomy, and physics until new theories emerged in the 20th century. In addition to his scientific work, Newton's approach to science influenced how research was conducted. His emphasis on mathematical explanation and empirical evidence became a standard model for scientific inquiry. This legacy extended far beyond his own discoveries. Today, Isaac Newton is remembered as a central figure in the development of modern science. His work connected the motion of everyday objects with the behavior of the cosmos. Through careful reasoning and disciplined study, he helped establish principles that continued to shape scientific thought. His life and achievements remain a key subject of historical study. They illustrate how individual insight combined with methodical research can transform human understanding of the natural world.